Hey guys, this is a quick video just summarizing everything from the 3M course. Okay, so we learned how to expand and how to factor. So to expand, we just, for this one, it's a couple of binomials. So we just multiply everything in this bracket by everything in the second bracket. So it becomes 3x squared minus 6x. And then we move on to the 1 and multiply it through, so plus x minus 2. Final answer, 3x squared minus 5x minus 2. So that's just how we could expand. And in this column, we're going to factor. So this first one is just a common factor. So both terms are divisible by 2, so we'll factor out a 2, and it'll become x plus 5. Then the next one is a simple trinomial, so it'll become x, what multiplies to negative 12 and what adds to negative 4? So all the things that multiply to 12 are 12 times 1, 6 times 2, 3 times 4. And then we just have to think, okay, which one would add to negative 4? I'm thinking negative 6 plus 2. So it would be x minus 6, x plus 2. That's how we factor a simple trinomial. And a complex one, we multiply these two terms together. And we're looking for something that multiplies to that number. So what multiplies to 24? Let's make a list. 1 times 24, 2 times 12, 3 times 8, 4 times 6. And now we need something to add to 11. So that won't work, that won't work. Oh, this will, 8 plus 3. And we're gonna replace this with 8 and 3. So 2x squared plus 8x plus 3x plus 12. Then we're gonna kind of cut it down the middle and common factor each half. So 2 and 8 are divisible by 2, and they're both divisible by x. So that leaves us with an x plus 4. Then these ones are divisible by 3. So that leaves us with x plus 4 once we divide them both by 3. And now, since these brackets are the same, we're actually going to take them out, so x plus 4. And then we're going to write what's left, 2x plus 3 in another bracket. And that's complex trinomial. Okay, so let's take a quadratic here. And let's find the vertex and graph it. So if we want to find the vertex of this, we have to do something called complete the square. So that's where you factor out a 2 from the first two terms. Like factor out this value from the first two terms. So it becomes 2x squared plus 6x. Second step, we're going to turn the bracket into a perfect square. So we take this 6, we divide it by 2, so that's 3, and then we square it. So that's 9. So you always do that. Divide by 2, then square it. So then we have plus 9, and then we can't just add a random 9, so we also have to subtract 9. And now we want to get the 9 out of the bracket. So when we pull it out, we have to multiply it by the 2. So it becomes negative 18 minus 1. And last step, we have to factor this. So multiplies to 9 and adds to 6. 3 times 3, 3 plus 3. So the bracket's going to factor into x plus 3, and there's going to be 2 of them, so we're just going to square it. And then negative 18 minus 1 is negative 19. I'm trying to go quick because it's just a review video. So then to find the vertex, it's the opposite of this guy, so negative 3. And this one, negative 19. So if we did graph that, would be tricky, but we'd be at negative 3 and then somewhere really low down, negative 19. So we'd be down here. And then to get another point, our our a value is 2. So I like to do it like this. I like to say, to get my next point, I usually would go over 1 from the vertex and then up 1. But since I have this, it's like a vertical stretch. So it's going to make this go up by actually 2. So it's going to go over 1, up 2 spaces. And then normally I would go over 2, up 4 from my vertex. But now I'll have to multiply that by my stretch. So then I would end up going over 2. And then I would go up 8, so even higher up. And I'm just going to draw a rough sketch. Okay, if we wanted to find the roots of a parabola, I forgot about that one. To find the roots of a parabola, so let's say we had like y equals x squared plus 4x plus 3. If we wanted to find the roots, we have 2 options. We could factor it, or we could use the quadratic formula. So I'll show you the factoring. So what multiplies to 3 and adds to 4? How about 3 times 1? So x plus 3, x plus 1. It's just a simple trinomial. And then I would just set y equal to 0. And then set each bracket equal to 0. So x plus 3 equals 0 and x plus 1 equals 0. And then isolate x. Or if that didn't work, you could sub a, which is 1, b, and c into the like negative b plus or minus square root of b squared minus 4ac, all divided by 2a, if you want. Okay, moving on. There could be a word problem. So like, say someone was throwing a baseball and then it landed on the ground. A word problem is really you're just trying to find either the vertex, so that's like the maximum height of the ball, or maybe you're trying to find when the ball hits the ground, which is going to be the root, or maybe you're trying to find this value, the initial height of the ball, which is just the y-intercept. So maybe you'll have to find some information about the parabola. Functions. Unit 2 is all about what is a function. Actually, I think the graphing part, this part, was actually in Unit 2, but that's okay. So to tell if something's a function or not, for every value of x, it can only have one y value. So for this x value, it actually has a y value here and here, 2 different values. So that is not a function. This one's fine because like every x value would just end up having one y value. So yes, this is a function. And this one is not because it has like 2 different values for some of the x's. We also talked about function notation, so replacing y with f of x. So if it asks us to find f of -3, we just sub -3 in for x. So this will become -12 minus 2, which is just -14. Exponential functions. So the main topics were this one, exponent laws. It's good to know all of your exponent laws. So power of a power is first. So if you have an exponent like this outside the bracket, you would just multiply it by each exponent inside. Even this 3 has a little exponent 1 on it. So this would become 3 squared, x to the power of 8, y to the power of 4, divided by 12x y to the power of 5. And then next, I'm going to change 3 squared into a 9. Next, you're simplifying. So 9 over 12, I'll just divide them both by 3. So it'll be like 3 over 4. And then with the x's, you're subtracting exponents. So this is an 8 and this has a 1. So 8 minus 1 would be 7. And for the y's, 4 minus 5 would be -1. So So you could put y to the negative 1, but we don't really like negative exponents up top. Like we don't even like negative exponents. So we're going to move it to the denominator. Because really, this is like you have 4 y's in the numerator and 5 of them in the denominator. So these guys actually all cancel out, leaving 1 y in the denominator. And this is our final answer. We also talked about graphing, so making a table of values and graphing. So like what would happen if it's -1, 0, 1, 2, and we just subbed x in. So we would get 1/2, 1, 2, 4, and then we graphed it. So it would have a y-intercept of 1, and it would go like this. It had an asymptote, we called it, right here at y equals 0. And that was just a spot where the graph got really close to, but it never touched. This one, 1/3, actually looks really similar, but it's going the opposite direction. It's going to be like a little steeper, but it's going to be going this way. And it actually also has an asymptote right here at y equals 0. I'll just write that. It's called an asymptote. We talked about domain and range too. So the domain, we talked about that in unit 2 as well. Domain for exponentials is x is a real number because it's going to go on in both directions. And the range for both of these is it has to be, y has to be greater than 0, like not equal to it though. Okay, we also talked about word problems, exponential growth and decay. So all the problems kind of are can be represented with a function like this, where a represents the initial value or amount. B is kind of like it's our base, but it's kind of like our growth or our decay rate. And x is usually representing time in our word problems. So if you had a hockey card worth $5, that's our initial value. It's increasing by 12% each year. So to write 12% as a base, first we have to change it to a decimal, so 0.12. And then, I don't know if this is helpful for you, but to find the base, we do 1 plus the rate, or 1 minus the rate if it's decaying. So this would be 1.12 to the power of x. So if you wanted to find out, like, how much would the hockey card be worth after 10 years? So 10 years later, you could do 5 times 1.12 to the power of 10, and you could calculate that. Okay, moving on. Interest. We just did this recently, so I'm not going to do too much on this, but we learned about simple interest and compound interest. So simple interest, that's what the I stands for, is equal to the principal, so the amount of money that you start with, times your interest rate as a decimal, and time in years. And then if you want to get the total amount of money, you just add your principal and your interest together to get your total amount that you'll end up with. Then compound interest, P still stands for principal, same thing. That's just the number 1. The I is going to be your interest rate divided by your compounding period. So rate divided by number of times it compounds. And N is going to be the years multiplied by the number of times it compounds. So if you had something compounding monthly, that you would be dividing that by 12 and multiplying the years by 12. So that's how that works. Okay, moving on, and then trig was our last unit. So we learned like 3 topics in trig. The first one was to do with right angle triangles, so your SOHCAHTOA stuff. So that was where like maybe you have to find a missing side. So you'd be like, okay, 28 degrees. This is the adjacent. This is the hypotenuse. So adjacent and hypotenuse. What do I need? I need cos. So you fill out your formula. Cos 28 equals adjacent over hypotenuse. And then your goal is, how good are your algebra skills? Now we want to isolate x. So sometimes we're going to multiply or divide or who knows, but x is in the denominator right now, which is not good. So I'm going to multiply both sides by x just to get it out of there. So those cancel, and we end up with x cos 28 equals 4. Then if we divide both sides by cos 28, we end up with x equals whatever 4 divided by cos 28 is. Sorry, I don't have a calculator, so you can figure that out. And then this one's just a bit different because you're finding the angle. So this is my opposite, this is my hypotenuse, so I have to use sine. So sine theta equals 12 over 15. In order to find a missing angle, you're always going to be doing inverse sine or whatever, inverse cos, inverse tan of whatever 12 divided by 15 is. And that will tell you your angle. Okay, we also learned sine and cosine law. So like this one, you have the angle and then two sides surrounding it. So I know I can't use sine law because I don't have anything like any completed ratios. So let's say I want to find this side and I know this angle. I would use this formula. A squared equals b squared plus c squared minus 2bc cos A. I would be subbing in like b and c and a and solving that, which I'm not going to do. And then this one, I know I can use a sine law because I have two things across from each other. And these guys are across from each other. So I like to put whatever the unknown is. I personally just like that in the top left. So I'm going to put sine theta over 18 equals sine 38 over 12. The angles always have to have a sign beside them, FYI. And then you just want to isolate sine theta. So I'm going to multiply both sides by 18. So now I know sine theta equals sine 38 divided by 12 times 18. So you'll get an answer like 0.92 something. And then to actually get your angle, what do? You do inverse sine of whatever the angle, I don't know, whatever the decimal is. And that will tell you your angle. Okay, and then finally we did graphing. So we talked about A, K, and C. So this affects the amplitude. So our amplitude would be 3. This affects our period. So our period will be, instead of 360, I'm going to have to divide it by K. So our period would be 180. And this guy affects our equation of axis, making it y equals -1. So we know -1 is kind of going to be like the middle of our graph. So sine normally starts at 0, 0, but you're going to take your x value and divide it by 2. That's what this k value does. Then your y is going to get multiplied by 3 and subtract 1. That's how you get all your values. So you divide by a, which is this guy. Oh, just kidding. So you divide by k, which is that one. You multiply y by 3. And finally, you subtract the c value. So that leaves us with 0, -1 for our first point. 0, -1. Our next point would be 90 divided by 2, so 45. And 1 times it by 3, so 3, minus 1, 2. So 45 and 2. Our next point would be 180 divided by 2, so 90. 0 is just going to be -1. So 90 and -1. 270 and -1. So 270 divided by 2, 135. -1 times 3, -3, minus 1, -4. So 135 and -4. And finally, 360 and 0 is going to be 180. And the zeros have all worked out to be -1. So 180 and -1. And that's what our new sine curve will look like. And it's going to go on in both directions forever. So you can put arrows at the end. Okay, and that's everything. Good luck, guys.